I'm Dave Boal. I was a professor of physics at Simon Fraser University for 30 odd years. First in nuclear physics and then in biophysics. And at age 60, I had a book which I was writing for Cambridge, and there was a disagreement about the art budget. And so I thought I had an art budget, but I didn't. So I wound up doing 300 odd illustrations for the book. It's a 600-page book. And basically, I realized that I'd sort of finished my career in physics, and it was time to do art. And so what I've done then in the 10 years that followed was return to painting, and that's what you see around here. So this is part of a triptych, and it starts in 1887. This particular piece was done in 1912, but it's derived from a piece in 1887 by an English photographer named Edward Moydridge, who developed stop motion photography. And what you see in his work from the late 1800s is the idea of freezing images of people moving. He does people, dogs, horses, the whole works. This particular piece was by Marcel Duchamp, an early Cubist painter, and it refers directly back to Moydridge's work. In fact, he used almost the same title for it.
So we're seeing one figure in different poses.
Exactly.
Right.
So he's trying to take then a static medium of acrylic painting, or oil painting rather, and you can see the motion of the calf down here. You can see the motion of the thigh as he's superimposed these here. And again, it's the motion which he's trying to capture. I don't know that he was one of the first people to actually try and use lines to indicate the movement as well. But so in reproducing his work, what I've done is tried to select from it, I guess, what I see in the imagery, that is the superimposed motion, etc. And also simplify the construction. So a lot of stuff which was in here, I've then pushed into the background. The idea behind the painting, like the whole triptych, was the DNA of art and how art evolves, which to me is a lot like DNA. It's cut and paste. So you take genes that work from one parent, genes that work from another parent, and you mix them together and you get something new. And the reference to DNA then is the double helix, which goes through here and goes through the rest of the triptych.
So these are base pairs.
Exactly, that's right. Not as much as people might think. So I found that as a teenager, I was interested in going to the Ontario College of Art or doing architecture. Once I moved into science, then those observational skills that you have as an artist are equally valid in science. And so towards the end of my academic life, if you will, after 30 years of physics, I sat down one night and I did a sketch of my wife. And I hadn't done that for, as I say, of the order of 30 years. I found that 30 years of observing figures, which I just couldn't do when I was a teenager, came quite naturally as someone who was 60 years old. And so I think in both fields there's this, how would you say, sort of this acute need for observation. You may not necessarily translate it into replication of what you see, but nevertheless you're trying to pick out the important features from what you're observing. So I think observation is really important. I think so, even though there's been a different job. So I think for the time being, when I was in physics, first in nuclear, then in subatomic, then in biophysics, I enjoyed all the problems that I was working on. In the nuclear area, it's the physics of the early universe, the physics of nuclear phase transitions and stars, and in biophysics, it's early life forms. There's the physics of the simplest cell design you can get, how easy is it to repair, what's its mechanical stability, etc., etc. So in those cases, like they're good, very good physics problems. So I've enjoyed that, and now I've enjoyed doing this. It's different, hopefully is creative, but probably only as we talked earlier, only my days as a chemist, which were always exciting in the lab because of the threat of imminent danger. As a theoretical physicist, I'm there with my pencil.
You're pretty safe.
Yeah. I mean, there were times I recall with at the Triumph Accelerator on the UBC campus where things were going sour and we had to evacuate the room.
Wow.
But I remember other things as a chemist where I was working on what turned out to be nerve gases. And we had a leak, and I'm looking it up, toxicity. There it was, number 2 in the list of most toxic. Every out.
Yeah.
So, anyway.
Yeah. It's about the film of your life. Would that to be one of the scenes in the film of your life? Well, David, thank you so much.
Okay, thank you.
Great.
Okay, thanks very much. Okay, great.